So our task is to predict the marks of a student using supervised ML. Let's get started. Our final aim is to predict the marks of a student based on number of hours he studied. So firstly, let's get into it and import all our libraries. So we have successfully imported. We've imported pandas, numpy, and matplotlib. Next, let's read our data from a remote link and convert it into the CSV form. This is done successfully as well. So let's proceed to the next step. So let's to get a better understanding of how our data is, let's plot a graph, and scatter graph is a really good one, so we'll do that. Here you can see we have done that, and let's run this. So x part is the number of hours and y part is the percentage of score. So let's proceed to the next step. So in the next step we have divided our data into attributes and labels. So x part is the attributes and the y part is the label part. So let's run this as well. Successful. So proceed next. Let's proceed to the next one. So next one is the one of the most important parts. So we have our attributes and labels. So our next step is to split the data into test and training sets. So we'll do this by using the scikit-learn's train test split method. So here we go. The 20% of the x and y values are given to the test part and the remaining 80 is given to the train part. So this is how we have divided it. So let's run this as well. So let's proceed. Next we have to train our algorithm, training the algorithm. So we have identified that linear regression is a suitable algorithm for this. So let's fit our train values into the regressor. It's done successfully. To get a better understanding, let's plot our regression line. So your regression line is nothing but a straight line in the form of y is equal to mx plus c. You can see here. So this helps us to get a better comparison of the data, so how it is varying to the standardized form, so we can get an understanding how our scatter plot values are varying from the regression line values. So here we go. Next one is predicting the scores. So why predict? So let's predict our scores using the test set values. So let's take a random x test value and predict its respective scores using the linear regression method predict. So here we go. These are the predicted values which is stored in y dash predict. Sorry, y underscore predict. So now let's make some more predictions. So here it is. And to get a better understanding, let's create a data frame and store actual values and predicted values. So here it is. These are the actual values and these are the predicted values. This is here it is. Actual versus predict. So our next step is to take a random number and predict its value. So let's take 9.25 hours. This means a person who studied for 9.25 hours, and let's predict his score now. So using the predict method, his score would be approximately 93.69. So let's proceed to the next step. From the sklearn module, we import metrics. So metrics helps us in analyzing our model a little better and getting to know whether it's a good fit or not. So let's take mean absolute error. We can take mean error or any other algebraic function as well. So here we are applying it to the y values, the actual y values, and to the predicted y values. So here we are getting an absolute mean error of approximately 4.13, which is positive. Mean error, absolute error is always positive, and it's a small value, which implies that it is a good fit. Our model is a good fit. So thank you.